Okay, in this video we're going to look at drawing dot cross diagrams for ionic bonds. Ionic bonds form between a metal and a non-metal. So if we look at our first example, we have lithium fluoride. Lithium is a metal, fluorine is a non-metal, so lithium fluoride must contain an ionic bond. We're going to start by drawing the electronic configuration, drawing the electrons for lithium and then drawing the electrons for fluorine. So lithium, if we look on the periodic table, has an atomic number of 3, which means it has 3 protons and 3 electrons. 2 electrons will fit in the first shell, and the third electron must go in the second shell. So protons are positive and it has 3, electrons are negative and it has 3. Fluorine. Fluorine has an atomic number of 9. Now I'm going to draw the electrons for fluorine as dots because we're drawing dot cross diagrams. So it doesn't matter which way around they are, but one atom needs to have crosses for electrons and the other one needs to have dots. So fluorine has 9 electrons, 2 in the first shell, 7 in the second shell. So it has 9 protons and 9 electrons. If you're struggling to draw these electronic configuration, have a look at my previous video on how to do that. Okay, to be stable, atoms always want to have a full outer shell of electrons. They want to be like the noble gases, group 0. These elements are all very stable, they're all very unreactive because they already have a full outer shell of electrons. Helium's got a full outer shell, neon's got a full outer shell, argon's got a full outer shell, and that's what all the other atoms are striving to be like. So lithium currently has got 1 electron in its outside shell, and fluorine has got 7, so neither one are stable. Is it going to be easier for lithium to lose 1 electron or to gain 7 electrons? Well, it's going to be easier for it to lose 1 electron and then it will have a full outer shell. Fluorine, it would be easier for it to accept 1 electron. It's got 7 in its outer shell at the minute. If it accepts 1 more, then it's got 8 and it's got a full outer shell also. So what we can do is we can represent an electron transfer with an arrow, where lithium could donate an electron and fluorine would gladly accept that electron to make lithium stable and fluorine stable. So I will draw an arrow which is called an electron transfer arrow, and this arrow shows where the electron will move. The most common mistake with this diagram is that people draw an X here and they draw the X over here. Well, an electron can't be in 2 places at once, and in this diagram it's important that the X is still on the lithium at the moment and the arrow just shows where it will move. We're now going to draw a second diagram that will show what these atoms look like after the electron has moved. So lithium, after it's lost this electron, is only going to have 2 electrons left. So it's still got 3 protons, but now it has only 2 electrons. Okay, fluorine is going to accept the electron. So it's going to have the 2 electrons in the inner shell, and then on the outer shell it's going to have the electron from lithium, which I represent as an X to show that it's come from lithium. So it still has 9 protons, but now it has 10 electrons because it's gained 1 from lithium. Okay, now if lithium has 3 protons and 3 electrons, then 3 positives and 3 negatives mean there's no overall charge. But after it's lost an electron, it now has 3 positives and only 2 negatives. So that means overall it has a slight positive charge. So I draw square brackets and I'm going to give it a plus on the outside of the brackets to represent the positive charge. Fluoride has still got 9 protons, but now it's gained another negative electron. So 9 positives, 10 negatives overall, it's got a negative charge. So I'll draw a negative charge on the outside of a pair of square brackets. It's important that you remember to draw the brackets. It's important that you remember these charges. There's a common mistake where people get these charges the wrong way around. An easy way in the exam to make sure you don't make that mistake is to look at your table of ions, which will be at the back of your exam paper next to your periodic table. It'll have a list of different ions and the charges with them. So at the back of your exam paper and the table of ions, it will tell you that for lithium, lithium forms Li+, and fluoride, it forms F-. So I suggest in an exam situation, you check the table of ions and make sure you've got these charges correct. Right, let's have a look at another example. Very similar, but slightly different here for magnesium oxide. Something else I'm going to start doing now is I'm going to make things a little simpler in that I'm not going to draw the inner shells of electrons. I'm only going to draw the valence or very outer shell of electrons. In your exam, you don't need to draw the inner shells of electrons to get marks, and it saves a lot of time and space on your exam paper to just draw the valence shell or outer shell. Okay, magnesium is in group 2, which tells me that it has 2 valence electrons. Oxygen is in group 6, which tells me it has 6 valence electrons. Make sure you're drawing one of them with crosses and one of them with dots. Okay, you can probably see already what's going to happen here, but magnesium wants to lose 2 electrons so that it has a full outer shell, and oxygen needs to gain 1, 2. So it has a full outer shell of 8 electrons. So this time we're going to need to draw 2 arrows to show electron transfer. This electron will transfer, and this electron will transfer. Okay, remember not to draw the electrons twice. And then we're going to draw the after diagram. What happens after the electrons have moved? Well, magnesium, we don't need to draw any electrons for magnesium now because we're only interested in the outer shell, and these 2 have gone. So I will leave magnesium as it is, and I'll put that in square brackets, and I will write the charge there in a moment. Oxide, 1, 2, 3, 4, 5, 6, but now it's gained 2 more electrons, across there and across there. Put that in square brackets. Now, because magnesium has lost 2 negative charges, it's going to have more protons than electrons, and it will be a charge of 2+. Because the oxygen has gained 2 electrons, the oxide has gained 2 negative charges, so it will have a charge of 2-. That's usually the bit, remember, that confuses people. Look at your table of ions and check your answer there, in case you're worried you've made a mistake. The table of ions will say Mg 2+ and O 2-. Okay. Right, one more example. Slightly different this one. We'll start off in the same way. Magnesium is in group 2. So it has 2 valence electrons. Chlorine is in group 7. So it has 7 valence electrons. Now, to gain a full outer shell, magnesium wants to lose both of these electrons, but chlorine only wants to gain 1. Chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. It only wants 1 more because it needs 8 in its outer shell to have a full outer shell. So the magnesium can easily donate 1 electron to this chlorine atom, but it's going to need another chlorine atom to donate this electron to, because this chlorine doesn't want any more than 8 electrons in this shell. So I will draw another chlorine atom. 1, 2, 3, 4, 5, 6, 7 electrons in its outer shell. And we'll do another electron transfer arrow. And we would now need to draw the after the electrons have moved diagram to represent the ions. So Mg, no electrons left in its outer shell. Because it's given away 2 negative charges, it becomes 2+. Check with your table of ions. And we're going to have chloride ion, which has 7 of its original electrons plus 1 of the magnesium's electrons. Now, each chloride ion has only gained 1 electron, which means it's only got a charge of -1 minus. But there's 2 of them, and rather than draw this out twice in your exam paper, to represent that there's 2 of them, we can just put a 2 before the brackets. So we've got 1 of these, Mg2+, and we've got 2 of these, Cl-. Again, sometimes people get confused here and they put, because there's 2 of them, they write 2-, which isn't correct. If you look in your table of ions, you will see in your table of ions it tells you that the chloride ion is Cl-, magnesium ion is Mg2+.